Hey guys, this is lesson 4.6 for pre-algebra. It is called Rational Numbers. So title your paper, Rational Numbers. Now, on your paper, I want you to copy down this circle chart. So take a minute, pause the video, and copy this down. All right, so first we have whole numbers, which are just that. They're a whole number, and it's only from 0 up. It's only positive whole numbers. Now, integers are everything positive and negative, so that's why they did it outside of the whole number circle, because it includes the whole numbers also. So integers are whole numbers, but they're also negative. So notice all of these four numbers are negative. So all of those four negative are integers, but so are these. These are also integers. Now, a rational number is pretty much any number that you can write as a fraction. Rational numbers are like 6/7, negative 3/4. It's positive and negative. And 21.84 with the repeating sign. Now, rational numbers are decimals, but they either have to repeat or stop. So they either have to, like this one, 0.25, that stops, or like this is negative 7/2, which is really negative 3.5. Those are rational numbers. They're not integers, because integers cannot have decimals, and whole numbers can't have decimals. So the rational numbers are the ones that have the decimals, pretty much. All right, so it says write 3 fractions equivalent to each fraction. So fractions, these are all rational numbers. So if I have 1/3 and I have to write 3 fractions equivalent to each fraction, this would be 2/6, and then 3/9, and then 4/12. 3 equivalent fractions. I just went right up. I just went right from 1/3 and doubled that, and then tripled, and then quadrupled. So negative 4/5. Negative 4/5, the easiest one is negative 8/10. And then you can times it by 3, so negative 12/15. And then what I do is times it by 4, negative 16/20. 5/8, you can have 10/16. That's timesing each number by 2. Then I times each by 3 and get 15/24. And then I times each number by 4 and get 20/32. You can do whatever you would like. It's not, there aren't only 3 equivalent fractions. There are tons of equivalent fractions. Negative 1/2. So negative 2/4, negative 3/6, and negative 4/8. All right, so example 2 is graphing a rational number on a number line. So here's what they'll tell you. They'll say graph each rational number on a number line, and you notice you have A, B, C, and D. So A, if I graph 1/2, it looks just like this. I draw my number line and I make a dot right on the number line at 1/2. Label it 1/2. So negative 8/10 is right here. I draw a dot on negative 8/10. 1 is here. Make a dot at 1. And then negative 0.2 is here. Make a dot at negative 0.2. So try this on your own. Push pause. Graph these 4 numbers, rational numbers, on a number line, and then we'll come back and go over. All right, so first I want to draw a number line. I look at my numbers and I see, okay, I need to go to negative 2 at least, because that's my largest one of these numbers. So I'm going to go to 2 on both sides, just to make it look symmetrical. So negative 1/2. So I'm going to make a tick mark. I'm going to draw a dot and then label it negative 1/2. negative 4/10. Now, negative 4/10 is less than 1/2. It's closer to 0. So I would make a dot here and label that negative 4/10. Negative 2, I can make a dot on negative 2 and it's already labeled. And then 0.9 is right almost to 1, and I label that 0.9. They just want you to see where each of them it falls on the number line. So if you were asked to put these in order from least to greatest, you would write, okay, negative 2, negative 1/2, negative 4/10, and 0.9. If I was asked to put them from greatest to least, I would do 0.9, negative 4/10, negative 1/2, and negative 2. It's just nice to see them visually. All right, here is a real world problem. So it says, the speed of a car changes from 37 feet per second to 102 feet per second in 5 seconds. What is its acceleration in feet per second? And then they give you the formula. So here's the formula. This is super important. And I'm sure you've seen this in like the MEP test or any other test. They give you a formula where A is acceleration, F is the final speed, and I is the initial speed, and T is the time. So what I do is I take that formula, A equals F minus I over T, and then I substitute my numbers in. So they told me F is the final speed, and they told me 102 feet per second. So that's where they put 102. And I'm going to minus the initial, which is 37, minus 37. And then I'm going to put it over 5 because they said, what is the acceleration in feet per second? So 5 is the time. So 5 seconds in feet per second, so you want the 5 right there. So 102 minus 37 is 65 divided by 5 is 13. Sorry. The car's acceleration is 13 feet per second. So try these where A, they've given you A and B, and they want you to write it in simplest form. So try A, B, and C, and then we'll go over. All right, so A is 6, B is negative 5, and then it's over negative 3. So 6 plus negative 5 is 1 over negative 3, and then that is in simplest form. So it's just negative 1/3. Now, the 1 is positive and the 3 is negative, so that makes your whole answer just negative. You can put it there, or you can put it out front, or you can put it on top, as long as there's only one negative sign. So here I have 7 minus negative 5 over 3 times 6. 7 minus negative 5 is 12 over 3 times 6, which is 18. And then I'm going to cut each of those in half, which is 6/9. And then I can divide by 3, which is 2/3. Lastly, I have 6 plus 9 all over negative 5. 6 plus 9 is 15, divided by negative 5 is negative 3. All right, that is it for your notes.